Welcome again to Oil Tech Pro. Today we'll be looking at the fluid flow through porous media. Fluid flow through porous media. When we talk about fluid flow through porous media, we are looking at a reservoir is an example of a porous media, okay? And also water through an aquifer is also an example of a porous media. And today we'll be looking at fluid flow through porous media, considering the basic parameters we must determine for fluid flow through porous media. Among these parameters, we must ask ourselves, what type of fluid are we looking at? The type of fluid is a very important parameter we must consider. And for this, we look at, based on the compressibility. Remember, we have talked of this when we are looking at the series on the fundamentals of reservoir engineering. We looked at compressibility, saying that it's a fractional volume change as a result of a rate change of pressure. The fractional volume change as a result of a change in pressure, which is the compressibility. And for our fluid we are considering, the oil, we have that the compressibility could be for the reservoir, we have the oil, the gas, and water. And so we have compressible flow, which exists in our gas. We have the incompressible flow, which exists in, we take our water, and we also have slightly compressible. So we have the type of fluid could be a compressible fluid, or an incompressible fluid, or a slightly compressible fluid. And slightly compressible fluid in terms of water. So using volume against pressure on this axis, we can have at various volume, we'll have this as our incompressible, our slightly compressible, and our compressible fluids. What this implies is that at any pressure, with any pressure change, where we have compressibility equals to -1/V dV dP. At any volume, if we take any volume rate, we'll have pressure being the same, but for incompressible fluids. But for the slightly compressible, you can see it slightly is compressible. You can see it moving slightly. But for the compressible fluid, this is an incompressible fluid. Okay? For the slightly compressible, for the compressible, you can see as the pressure increases, the volume change is also high, showing us that compressibility is taking place. Alright? We can relate this in terms of density. Where the fraction of density against the differential change over the change in pressure will give us, plotting the same graph, we'll have, if we take density on our y axis and pressure on our x-axis, we'll have that the density for an incompressible fluid will be like this. This is for an incompressible fluid.